Okay, all of them.
Okay, all of them.
We're always hiring.
If you haven't been here before, Envision is hiring. Always. We are always hiring. On that note, I want to go through at least a few announcements. We always do some open time for looking for work or hiring. I will start off by saying that Funkhouse is going to be looking to bring on some more people pretty soon. If you check out our work, funkhouse.us, we do web development, yes.
What kind of work are you looking for?
We are looking for front-end development work. That's where we're going. We're looking to bring someone on to do, we do portfolio-style website stuff and design and whatnot, but the role will be mostly WordPress and front-end development. If you're familiar with our work, sort of motion-heavy, high design kind of stuff. That's if you're into that, it's cool. And so, yes, we're not officially don't have a job posting right now, but I just wanted to put it out there that it's coming up. So I will probably send that to the group, whatever that is. But in the meantime, if you have interest or if you're interested in anything that I talk about today, find me afterwards and let's talk. Be good. Anybody else hiring or looking for work? Yes.
So I teach in programming in college, and I'm going to conversion of classes here, trying to bring in people from both community work and previously. So if you're interested in coming up, I see for now we're talking.
Awesome. So people that are interested.
I will say there's quite a lot of loans coming from my classes.
That's good. So any topic in particular, if anyone?
Actually, I'm covering, we're doing full stack backend kind of stuff, not as much front end stuff, but we're going to do some design. And we do have kind of companies that are looking at
Got it.
So having you guys tell us what's that is
Nice. All right. Find Doug afterwards if anybody wants to contribute to his class. Anybody else? Yes.
Taxjar is hiring. They're 100% remote, looking for PHP and Ruby developers. We're also starting getting replacers. Also some project management stuff in there if you're just in that kind of role. But taxjar.com, they're your company. Come on.
Nice. All right. Yes.
Those people who don't know your Wi-Fi password.
Yes. Wi-Fi is Funkhouse, which I'm sure you can guess. The password is Ithaca City, all lowercase. Anybody else? General announcements, hiring, looking for work, or want the Wi-Fi password? Yes.
If you like Gophers or Golang or Snickers, just come back from GoCon. Lots. But
That's what I'm talking about. We don't have enough of that. Besides, go places.
and at some point I have 2 Envision t-shirts that I need to figure out how to give away. That's a teaser.
T-shirt cannon?
T-shirt can in my jam.
We got 2 presenters. I can bring them with me.
I like wrapping them off. Maybe I'll get some on Slack. Incentivize people to join stuff.
There we go.
That's good.
Join the Slack channel. If you're not in there, join the Slack channel. It's a great time. It's not super active, but there are important things happening in there, and you should join. What's that?
Is there an auto join link somewhere?
There was on the newsletter and news group discussion what the heck. One point not.
We should put that in
Like on the meetup?
we should put that in the description of the meetup, probably.
Yeah.
I think, right, with the Trello link. I don't know right now, but maybe.
We'll figure out a way to try to make it more positive.
We'll do that, and we'll drop it in the Slack channel. Just kidding. Okay. Trying to think of other announcements. You know what? Is Singlebrook does our meetup dues. I always forget that one, and I'm really sorry about that. Any Singlebrook people here? No? Okay. Well, they do our meetup dues. Cool. Am I missing anything? No? All right. Let's get started. Everybody give a warm welcome to Timothy. Next previous laser pointer, if you want it.
Okay.
It's kind of falling off, but it'll work.
Next previous laser pointer. Got it. All right. Thanks a lot.
and I am doing IoT for, and I repeated that twice on this slide because there's a lot to IoT. And it's sort of like saying, let's do web development in 30 minutes, only with all of electronics as well. So I think I gave a lot of thought to how to do that. Oh, so here's my motivation is basically this thing here. I spent the last year taking an existing electronic product, consumer, agricultural, about 50,000 installed units, and basically making it accessible from your phone. And so this is, I've been doing web and software development in general and electronics for a long time, but that was sort of like my big experience with IoT. So I don't want to sell myself as an expert. I am a veteran, I would say, from this much, and particularly the last year. And I also thought about how to encapsulate an intro to IoT into half an hour-ish. And I sort of settled on, I felt like I didn't really want to do a postpartum or a case study on what I just did because that seems too specific. And a tutorial from the bottom end of like, here's how you could get started is also a plausible talk. Both of those are plausible talks, but I felt like I have some lessons learned from this experience and I wanted to kind of synthesize them into an overall orientation. So rather than give you the trunk of the elephant or the tail of the elephant in the old familiar metaphor, I would like to try to give you my idea of what the whole elephant looks like. There's a lot to it, so I'm going to talk fast. But feel free to stop me if there's anything that's unclear. So IoT, Internet of Things. It's this general idea that, hey, every object in the world should be addressable by an IP address, and you should be able to do stuff with it, right? Because that will make everything better. And whether it will or not is a whole other topic. But a little bit of history. 1982 is supposedly the first IoT device. Carnegie Mellon, they connected their Coke machine to the internet so that you could tell when your favorite drink was actually stocked in the machine and what temperature it was. 16 years later, it was still so weird that it was a source of humor. It was this April Fool's joke. Somebody at Xerox PARC put out an RFC on how to make a protocol for coffee machines on the internet. And this idea of an appliance on the internet was just so funny that it was a joke. And the main relic of that is HTTP response code 418 is still basically, if you look up the list of response codes, it's still on that list. This was an error code that said, you're asking me to make coffee, but I'm actually a teapot. So as late as 98, that was still funny, which meant it's sort of at the limit of culture and at the limit of even geek culture. That's about when this term was coined, and then only 10 years later, there were more things than people on the internet, more IP addresses assigned to basically devices than to people. So that's been a pretty rapid development. But yeah, what do we mean by things? We kind of mean device is sort of the generic term that people use when they're talking about these designs. But clearly, we're not talking about computers or phones or the other things that we normally interact with and have on the internet. We might call it an embedded device to distinguish it from other things like computers, but what does that really mean? It might mean a device that has very little UI, more like a Coke machine or a toaster. Maybe it's got some UI, but not much. But yeah, why is that important? It kind of comes down to this, that it's something that is autonomous, that's doing stuff on its own without direct user interaction. And that basically totally changes the normal way that you work on the internet. And this usually means that it's custom hardware. It's electronics that need to be designed for the purpose. Which leads us to this. How many people here have ever, let's say, coded something for an embedded system that you're, okay? Downloaded code to a microcontroller, used Arduino, made something out of chips, hooked together a couple things with wires. Okay, good. That's what I was thinking, since this is the Web People Meetup. So I thought I'd do a quick run through really fast of the world of electronics and custom hardware. You might think that it's like a whole other world from software, but really it's kind of like buying a computer. Like you can, spec out your computer and either assemble it yourself from components or sort of say, here's the motherboard that I'd like and how much memory and stuff. And it's very similar to that, especially now. The building blocks that you use are more things like microcontrollers, which are an entire very small computer on one chip. Then there's single board computers that they can range from a microcontroller with a few extra parts that make it easy to just sort of hook up to your computer and download code to, all the way up to computers that are essentially a full, you could make a desktop system out of them, but they are $30 instead of $300 or $3,000. You can also add sensors, actuators, displays. So sensors are things like temperature sensor, buttons, pressure sensors, lots of different things that you could hook up. Limit switches that tell you something's moving in the real world and it's reached this limit. Actuators are things like that have an effect on the real world, like motors, heaters, other things that are escaping my mind right now. Displays range from LCDs, sort of touch screens, down to single LEDs that you could maybe change the color of or blink. So there's a whole wide range of stuff that you can hook together. Oops. Then you have connections between them, which range from a single wire. If you're controlling an LED, you might just sort of hook it up to one wire, which always means two wires, but that's another story. And then bit-mapped parallel wires or serial protocols, which are sort of just more complicated ways to hook things together with two or more wires. Some of them are familiar, USB. You can use USB in embedded contexts. You can also use other serial protocols that are better, maybe more adapted for cheap small parts, like I2C and CAN is used in a lot of automotive things. SPI is used for memory chips. There's a bunch of those. But essentially, you're kind of just hooking stuff together with wires. And then you often will add some code. And the code that you're writing is in familiar languages. One of the most common platforms is Arduino, and they make a big deal of how they have this really easy to use language called processing that anybody can learn. And what processing is C, except with a little bit of sugar around it that help you kind of start off your project and give you a form for it. But they've got lots of newbies and school kids writing C without knowing it. And it also actually is C++, so that's sort of a common language. But there's also single board computers that run Python, JavaScript, all this stuff. So it's basically a way of writing code that runs on a computer, but a computer that is as small as you want to make it, physically, in terms of cost, whatever. Let's see. Oh yeah, so here's just a few examples. If you want to get into this, you absolutely can. The tools and tutorials and stuff out there right now are incredibly rich and make it so easy to get started and cheap. You can get, these prices are for an individual board or unit of these things. If you're just getting started, you might want a few extra parts, but Raspberry Pi, for between 10 and 35 bucks, it runs Linux. You can connect a keyboard and a monitor to it directly, or you can plug it into other sensors. You can build it into an appliance. It's probably the easiest thing to get started with if you're familiar with Linux. Arduino platforms are in a similar price range, and They're kind of more appropriate for lower level manipulation of sensors. You've got lots of code for dealing with things like motors and direct control over things that are time sensitive. Raspberry Pi is maybe better if you want to leverage some libraries that you're used to, or you want to do Python with image recognition and you're familiar with that. And then at the very low level, PIC and AVR are two of the most common microcontroller chips. And that, you can get one of those for $1 or $2 and run your code on it. And you might need a little bit more work to get the extra, power supply and LEDs or switches or whatever you want. But that's so sort of a spoiler alert. That's where you tend to end up if you're going to make a commercial project. This end of things is more for DIY. This end of things is more for commercial. And I'll get into that a little bit more. But those are excellent entry points if you're interested. Those two companies, SparkFun and Adafruit, are very software developer friendly. There's lots of kits and tutorials. They're very cheerful and community oriented. They both endorse open hardware, which, if you're not familiar with that, it's sort of an analog in the hardware world to open source software. The idea is they'll sell you the piece of hardware, the little board or whatever. They will also provide all of the design documents, schematics, parts lists for that, and everything that you would need to make it yourself. They're sort of saying, you can buy it from us, we're happy to build it for you, but if you want to build it in larger quantities, well, we'll still sell those to you. We could sell you 50 or 100. If you want to make 1,000 or 10,000, you can just take the designs and have them made yourself. And those Mouser and DigiKey are two other websites that are more engineering focused. They've got every single part that there is. So that's sort of how to get started if you're interested. This is a little brief bit about what the difference is when you're taking something commercial, just from the hardware side. I'm not talking about the IoT side yet. There's some things that change that are different from the software world. In software, you can make a copy of your code for free. And you can add another user onto your server for nearly free. In hardware, you've got a per unit cost. That's like back to the old economy that we used to have in this world. And that ends up dominating a lot of your design and the way you work. Even saving $1 per unit can be really significant and worth a lot of time. If I'm selling 10,000 units a year and I can save $1, and that lifetime of that product is 5 years, that's $50,000 that I could spend just on designer time to tweak that and save me that $1 off of the bill of materials. That ends up being very, very important. Availability is another thing that's like alien to software developers. You've got a library of code, like it's always available. You keep a copy of it or you get it off of NPM or whatever, but this is not the way the physical world works. You have lead time. You can say, I want another 100 of these boards, and maybe they're in stock at one of those websites. If you want 10,000 of them, maybe you can get those, but maybe it'll take 6 months. And that may not play well with your plan for when you want to release those 10,000 units. Also, if you've been building units for the last several years using these parts, and the supplier for that part suddenly says, oh, we're no longer carrying that, you have to redesign, and redesign may mean changing a hardware board and a bunch of other cascading things. So you want to look for stuff that's going to be highly available and not change very often. And if you're buying from a single source, if you've got sort of, you're tied into one company's ecosystem, you're subject to whatever happens to that company, more so than in software, because there's stuff like, oh, that container got lost in customs, or there was a tsunami around that factory, and so that gets a lot more interesting. Also, design for manufacturability is a big thing in electronics, DFM, and there can be surprising things that you didn't think about. For instance, if you say, oh, we'll just have a serial number on each device, and that will allow us to do the following things. That can drastically increase the cost of manufacture because of the way assembly lines work, and chunking out a bunch of identical units is cheap. Chunking out a bunch of units that actually have to be serialized ends up often being expensive. You can do it, but it may cost more. I've had situations where adding an external antenna is like basically impossible for the price point that the customer wanted, because the only practical way to attach these antennas to these chips was through this one connector, and there was like no mass producible method for connecting that connector. It was like a manual, sort of error-prone connection. And it gets into things like, how do we want to package them? What kind of different SKUs do we want to use when we're selling them through our distributor? So there's a bunch of all this stuff that is surprising when you get into commercial. Okay, back to IoT. And this is the section which is sort of my attempt to synthesize lessons learned about what it means to be doing something in IoT, particularly from a commercial standpoint. So at the most basic level, it's a similar architecture to what you're familiar with. If you cover up this stuff at the bottom, there's some users on some devices talking to some server. The only difference is that you've got some devices talking to that app server. They're maybe going through Wi-Fi or some other connection mechanism, but that's not that unusual. There's this mysterious gray line called provisioning, which basically means how do you tie that device to that user? I mean, I'll get a little bit more into that in a minute. But other than that, it seems like it's sort of the same deal. These are some of the differences. You sort of, because of wanting to reduce the cost as far as possible, you never get any resources for free. You never say, well, we've got a lot of memory, or we've got power is no big deal, or CPU power is available. You only have as much as you want to afford, because if you can get by with a chip that's $1 cheaper, then that's what you'll do. So you're kind of constrained on all these resources, or you'd like to constrain them as tightly as you can. Also, most people, even the most fanatical devotees of your website, are not going to be on it 24/7. Many IoT applications do have 24/7. It's full time that the device is connected to your server. And they may be connected, so it's common that you'll connect through consumer Wi-Fi. There's other options, cell connections, lots of things. But when you're looking at it from a point of view of wanting to be connected 24/7, those connections are not that great. Like consumer Wi-Fi goes down all the time, and we don't, we kind of hit refresh or reboot the router or whatever, and we're not that aware of it, or maybe you are. But if you're monitoring something, that's a pretty flaky connection. Time series data. It's again, because you're often monitoring something 24/7 and collecting bits of data every so often, you've got this. You're often building up a tremendous time series of sampled points. And you almost never want to access it that way. You want to know what's the minimum over this time period, what's the maximum, what's the average, or you want to be alerted when it goes over a certain level. That's not really very similar to like a SQL database that you're using to store somebody's account info, or an individual transaction that's happening at most a few times a day. So there's some unique features about time series data. Oh, and you still have users wanting to access their data. So you've got this intermittent user who's doing this kind of stuff, and then you've got this permanent device that's doing this kind of stuff, and the two kinds of stuff are pretty different. And you've got this device provisioning issue. I guess this is as good time as any. The main problem there is you've got this very simple device. It has, sort of by definition, no UI or as cheap a UI as you can get away with. And you probably have to set it up, and at least, you know, if you're using Wi-Fi connectivity, you have to get the Wi-Fi station chosen and the password input, and you also have to link it up to the user. How do you do that when there's no UI on a device? There's a bunch of different approaches, but that is sort of one of the features of the landscape, is that you got to solve that problem, and it can be central to what you're doing. Architecturally, parts of it are familiar. You've got the interactive side is the same as it was, but you may also have some other types of servers. If you're doing microservices or a lot of APIs in your implementation now, that may be familiar. You may also want to do message servers. One of the aspects of having something trickle a little bit of information all day long is that you want persistent connections that have very small packets individually. So you don't want HTTP, essentially. You want something that is just, this number's changed, this number's changed. You don't want all the headers and the request and the reply. So you want probably a different type of server. This boils down to, yeah, you've got a device interface that's different from the user interface, and so you have multiple interfaces to your product. What I just said, you probably don't want HTTP for the devices. You also may want different storage, different databases or different servers for your account data versus your time series data. You kind of probably want both in a typical IoT app. Because they're just different kinds of data. And what this leads to is you have an inherently more diverse architecture. I'm going to show you a scary picture now. This is, I guess it's not that scary. This is the architecture for the product that I just finished. It's, each one of these is a server with its own little ecosystem of code. There's a couple of microcontrollers down here. I don't want you to get too lost in that, but just to say that you may end up with a pretty diverse set of servers and a bunch of code bases. I think I have, well, there's probably at least 6 GitHub repositories that all work together for this product. For DevOps, oh yeah, this is maybe an overstatement, but it's sort of, you've got all these diverse little devices just sending packets all the time. It's a little different. So one of the things about these devices is they're all programmable, but we call it firmware instead of software, and it's because it's a little bit harder to change. You can usually have a device update its firmware over the air. OTA updates is the buzzword. It's a little, you have to be very careful about that for security purposes as well as just general reliability. You can update the firmware on a device from afar, but it's a little more complicated. So it's a little firmer than software. And that's really that's the downside, is you really don't want to break your updates because then there's a physical device that does nothing that has to be mailed back to someplace and exchanged. And that is bad. So you end up with this very diverse architecture running on many platforms simultaneously. It's lots of fun to debug. So that's another aspect. Security. is, yeah, so it's a complex system. That means that there's a large attack surface. Each of those servers, you've got to be really on top of the security implications for each of them, as well as for the devices. If you're using as cheap a device as possible, encryption may be expensive. I ran into an issue where you could do SSL on the device that I'm using, but you can't have a very large packet at a time, or else it'll blow out the memory on this node. So I ended up having to throttle encrypted connections in terms of bytes per second, so that it would always be just as much as the device could handle. They are an attractive target. There's sort of a general feeling that in the rush to explore this frontier, security is kind of the last concern. And you end up with all these devices, famously, webcams or whatever, that are just kind of brain dead about security and very easy to hack. And then you get some botnet saying, oh, let's exploit that. And now we have 10,000 or 100,000 devices that are great for DDoSes or whatever. And IoT is often used to monitor and control parts of your infrastructure. If you're talking about food supply, water supply, and energy supply, like that's now interesting enough to be on the radar of state actors instead of just people who are trying to steal your credit card. And that can be, I'm trying not to think about that, but I need to think about it. That's another level of scary. And yeah, like you may have to work harder. I think if you're doing web development now, the browser will be sort of persuading you to use SSL and to use encryption and good certificates all over the place. There is no equivalent in IoT because it's still so much of a frontier. There's a lot more feeling like, oh yeah, and you could encrypt it if you want to. So that you're kind of fighting against that. Business-wise, this is a big one. I have not yet found out exactly the extent of this, but we're doing a Wi-Fi connected product, and one of the scary open questions is how much time are we going to spend supporting people's consumer Wi-Fi routers? So far, it's been okay, so we'll see.
Maybe even worse if it's in a managed environment.
Oh, I believe it. Yeah. Yeah. Compared to traditional hardware, you sort of have all the software side, supporting your servers and making sure somebody understands them and what's going on maintenance-wise long term. The upside is you can maybe charge people a subscription fee for using it, which before you weren't able to really do because you're selling them a box. Now it's a network-connected box, so maybe you can plausibly charge them a bit a month and recoup some of those and make a little more profit. Compared to traditional web apps, yeah, you got this now, per unit cost and manufacturing stuff, all the stuff about selling something physical. Another interesting upside is that you have a physical object that's in a consumer's home or in somebody's workplace that they're looking at every day, even if they're not interacting with it. And that kind of object permanence can help out your brand. It's an opportunity to, it's harder to change providers if you've got the box on your desk. So that's the opportunity there, one opportunity. Oh, and I want to make this point. There's these, I think of it as sort of three levels. There's the hobby or do-it-yourself sort of home automation stuff. There's the consumer side, sort of white box appliances, or in our case, we do this sort of agricultural application, but it's for small farmers, so it's sort of directly to consumers. Feels like more of a consumer product. And then there's sort of the enterprise side, which is, the big enterprise deployments of stuff. those three end up, I think, looking very different from one another. And so, and they're all equally valid, but some solutions that are out there that you could plug into are much better adapted to one of those three than the others. Okay, let's see, why is this slide here? Okay. We're talking about networking options. I feel like I'm into the part where I'm talking about specifics now instead of generalities, but let's see. Networking options. You've got Ethernet, traditional wired. If you can deliver power over Ethernet, that's cool. But the cables are often a little bit cumbersome for people to route places if they don't already have them. It can be great for commercial deployments that are already doing that. Zigbee is a mesh networking protocol that came out 10, 15 years ago that is great for peer-to-peer. And it was originally designed for home automation. You need a separate box to get it to the rest of the internet. That's its downside. Wi-Fi is a pretty sweet spot for a lot of products. It's relatively ubiquitous, but it's also kind of flaky, but it's also ubiquitous. What I mean by this is that it's hard to run it off of batteries. There's some experiments with low power Wi-Fi, but it's pretty good when you've got something that's plugged in somebody's house. And then Cell is a lot more expensive to run, but obviously great if your device is moving around or if it needs to be outdoors. I feel like I missed a slide that was introducing this section of details and examples. That's what we're doing though. Okay, so devices. I'm assuming that you need something that is a radio plus a microcontroller, and that's sort of a generic way to go. Espressif is all the rage now. This is a microcontroller plus FCC certified Wi-Fi radio that costs about $2. And that's just insane. There used to be sort of a general limit of about $30 for anything that was FCC certified. I'm going to pass this around. I can start there. There's a little silver box on there, and that is one of those. The rest of the board is the radio board for our product. So the little silver box is the computer that runs everything that's on that device node, and it's also the radio. You can see a little tiny zigzag gold line. That's the antenna for the radio. In addition to only costing a couple bucks, you can get it from lots of places. It's sort of roughly open sourced hardware, and a lot of Chinese factories are making them, in the hundreds of thousands, so they're really easy to get. Particle is probably a more solid platform than Espressif. It is you've got the single vendor lock-in. They make a board that is pretty similar to that one, a little beefier. The firmware on it that you have to work with in terms of things like encryption is a lot nicer. They provide the servers that process stuff. They sort of give you a platform to start with that's plugged into their databases, their servers. I was a little scared because it's a single vendor, and you're sort of reliant on them not just for running the service, but for supplying the devices. As I was saying before, having a single supplier for hardware is a bit of a risk. Last time I looked, their devices were around $10, and there was about a 6-month lead time to get them in quantity. And that's pretty risky for the hardware side. But they're very popular, and they seem to have a really solid platform. And they also support cell phone as well as Wi-Fi. There's a bunch more. I'll have a couple more that I'll mention. And Arduino is kind of a brand leader. Both Particle and Espressif can be programmed through the Arduino IDE, which is kind of nice to sort of take a new device that you haven't seen before and sort of plop it into a familiar IDE. Once you've learned sort of that programming approach, which works across lots of microcontrollers and boards, that's pretty nice. Connecting the device to the server. Traditional REST frameworks are totally an option. You probably want to do it over HTTPS. The main thing is that it's expensive per connection. I mentioned that a little bit earlier. Every request that you have has the HTTP headers and that conversation. MQTT is a protocol that was sort of designed as a standard alternative to that. It has a persistent connection, and you just sort of throw these small packets back and forth that say, here's the change in my sensors. It's getting pretty ubiquitous. Their whole approach to encryption is, yeah, whatever you want. Go ahead and do it if you feel like it. But you can do it over SSL, and that seems like it's okay. Another option that we ended up with is WebSocket connection from the client to the server, and then using sort of ad hoc binary encoded messages. Because what you're typically passing is so small, it's not that big a deal to use an ad hoc protocol where you're just sort of saying, oh, I've got these 4 or 10 sensors, and here we go. There's the new bundle of data. Okay, device provisioning. This is the full slide. Probably a better place to put this would have been earlier. But there's this problem. You've got this device with a lame UI. How do you get it all set up to begin with? A common general approach is to grab your phone or your desktop or something and have something running on that asks you for your Wi-Fi and your password, and you go through that to connect up to the device, which is configured so that it's presenting a Wi-Fi access point. You sort of bootstrap it by having it come up the first time you turn it on, and it's saying, okay, I'm a Wi-Fi access point. You connect to that, and that's how you pass it in its initial data. That's what we ended up doing. There's some other platforms that do that. It's okay. It's pretty good. It's not completely simple for all customers, but people are kind of used to connecting to a Wi-Fi network with their phones, and that's a pretty good model. There's some other things that people are experimenting with. Taking your phone, running an app on it that will flash LEDs, or it'll flash a pattern that will be received by optical sensors on your device and sort of transfer your data directly to the device that way. It's kind of cool. It's also, when it doesn't work, it's because, you've got fluorescent lights that are interfering it or something. That can be kind of annoying. Scanning QR codes on your phone can be part of it. So there's somebody who does audio signals to kind of, you plug into the headphone output of your phone and then hook that into the device. We're still sort of in a frontier level of experimentation and trying to figure out how to do this the best. So there's some stuff that leverages like Amazon's enterprise level device allocation stuff, Google's authentication stuff. Like everybody has a menu of different things that you can use now. Yeah, no consensus. Data flow, there's the main idea is that you can build a monolithic server that has a bunch of separate interfaces for all these different pieces that you want, and that is the approach taken by those 4. It's attractive because it's kind of simple for implementation. It's not very customizable, We ended up using Blink as the main server with some other stuff attached to it. And we'll see how it scales. The other option is to kind of assemble your whole architecture from individual services that talk to one another, often with a pub-sub kind of model, publish and subscribe. Interestingly, one feature of the landscape is that Amazon, for instance, talks about this as their IoT. Their IoT offering is essentially a pub-sub server. To me, that's not like all of IoT, it's one piece of it. But that is something that if you're exploring this, you'll see some IoT offerings that are platforms and some IoT offerings that are a pub-sub server. And there's no consensus about how to use that term. Storage, I've touched on this. Your metadata and your time series data, basic idea is that they're different. SQL, any kind of SQL database or any kind of database is going to be fine for metadata. Time series is a little bit trickier, and I'm looking for a better solution. The Blink server that we're using is essentially using a NoSQL type file store that they rolled themselves, and it's okay. It's optimized for really fast shooting of packets of data out to the user when they're viewing it with the client. But I don't feel like they've totally pegged all of it. Oh, this is a key thing. In this, if you have this sort of complicated thing where you've got devices that know stuff about their environment, you've got the user who's talking to you through their web client or whatever, you've got the server. Each of those can have ownership over different pieces of data. I had some examples that are in the notes that I need to find a good way to access while I'm giving a presentation. But if you have your sort of your standard profile info,
Is that these right here?
yes, thank you. There we go. Right. So if you want to, thank you very much. If you prefer Celsius versus Fahrenheit for viewing temperatures, that's like a profile datum that you want stored. You want the user to be in control of it, and it's probably stored on the server somewhere. Similarly, their cell phone number, but the server needs to do something more with that. It's the client that needs to do something with this. The firmware version, the device knows it, and the server may need to know it, and the client may need to do something differently depending on it. And the temperature readings are the things that the device has firsthand knowledge of, and they're passing it off to the server. All those are kind of different levels of ownership and locales of ownership. So a recurring issue for me was realizing that I can't treat them all as the same type of data, and I can't set all the defaults for those in the same place because really it's different devices that are in charge of those defaults. This is the familiar part to people sitting here. You've got ultimately a user-facing client and server. There's this aspect that, I mean, everything is moving toward mobile. We're all familiar with that. In IoT, somehow it feels like it's even more mobile native than anything else. I'm not sure why exactly, but it sort of feels like you really have to have a mobile strategy. If you're doing provisioning through your phone, if you're assuming that the user has a Wi-Fi enabled device that they're going to use for provisioning, and you want to manipulate their Wi-Fi connection, you probably need to have a native app that's running on their device to do that. But you might not. We've been using progressive web apps and essentially telling the user to switch Wi-Fi networks when they have to for provisioning purposes. And so far, it kind of works. And that means, like, that's, in our case, the only thing that we really needed a native API on a phone for. And if we didn't, once we experimented with not using that and having the user do it instead, that means that we can use a progressive web app, which in turn means no native development and no fuss with native app stores. To me, that saves so much effort and time. It means that I can change a feature in the client and have it rolled out in 20 minutes to fix somebody's problem, rather than having to release it to Google Play or the Apple Store and wait a week for that update to get approved. I'm sure there are people who have had more experience with the app stores than I have, but at least getting started, it was like, oh my God, this is crazy. So progressive web apps have been really good for us. And if you're developing for progressive web apps and or mobile native and or browser, I've been having a good experience with Ionic because it supports all of those via Angular. And we're using Blink for the app server essentially. It's an interesting IoT-centered system. They provide the client, but we're ignoring that and building our own. But that is pretty useful for prototyping. You can get up and running on their server with a mobile app in like an hour. That's the way they advertise, and I did it. I got the device talking to my phone with a decent looking user interface in an afternoon. Great for prototyping. We ended up abandoning it for the UI because we just didn't have enough control. It's kind of like drag and drop your widgets around on the phone to build your UI. Not enough control for a consumer level app, in my opinion. Okay. How are we for time?
A little over, but it's
Okay. All right. If people have questions, we could start taking them. I have a couple more slides of my questions. I guess I'll just show them quickly. How costly is it to support Wi-Fi? Are people going to pay monthly fees? Will they, like, we're kind of at the cutting edge of this stuff. Will they expect it to get better? And so have high demands for how easy it is to set things up and use them? Or will they be more tolerant of this stuff because they've been using their Roku or whatever kind of, or Chromecast, like they've been using a bunch of devices that have similar procedures to what you do for IoT, and they're okay with that? Yeah, or a little bit of both. And yeah, like, what are the security implications of all these, like, probably underprotected devices proliferating? Like, is this going to totally bring Western civilization down? Or, will it end up being okay? And technically, like, will we get sort of a standardization of the protocols, message transports? Will there be somebody who has a totally plausible platform that says, okay, this is where you go, you can get started, you could bring it to market? Time series database, again, like, I'm still searching for a really good solution for that. But this is the frontier, and so it's like, it's kind of exciting to see it all start to shake out. All right, that's what I've got. Any questions? Thank you. Thanks. Mm-hmm. Say that again. What's the name? InfluxDB. Okay.
Yeah, it's kind of got a lot of traction in time series.
Okay. Great. Excellent. Influx. Yeah. Was that what you were mentioning?
I was just thinking about, from the security standpoint, it seems that a really good framework could possibly eventually solve that. Like, I was thinking about back in the day before we had MVC frameworks for the web, people were totally getting hacked by SQL injection.
Right.
And someone came up with ORMs, and all of a sudden that wasn't a problem anymore.
Right.
Are there any kind of
Yeah, I think Particles framework seems like the most solid for security as well as everything else. The trouble is that there is no complete framework yet at all. So, but their framework is pretty good, except that it doesn't have anything for the client. So basically, it gives you APIs to connect your client to. You build the client on your own, which is not bad. Right, yeah. And so they're handling the device side and the server side, so they can deal, I think they have a pretty good head for security. It's just that they're so expensive and it's a single source.
What is it called again?
Particle. They're the ones who are like $10 a node versus $2 a node for Espressi, for essentially a similar level of functionality, but a lot more build your own.
So there's really a market for a good open source IoT.
Yeah, and that's what Blink is sort of trying to be. They're too small a group to kind of make it so far as a comprehensive, like they're trying to do the front end too. I'm like, dude. They did, yeah, yep. And Particle did too, I think. And not that many years, maybe 8 years ago for them, maybe 4 or 5 for Blink. Yeah.
Did you look into CoApp and DTLS at all?
What was the?
CoApp and DTLS?
No, I don't know those.
That's like UDP-based SSL and HTTP design.
Okay. Okay. Interesting. Uh-huh.
So what were some of the drivers for you in splitting your backend services up? Just curious, so what some of those inflection points were that you said, oh, we got to split this up?
It was basically, we thought maybe we could use Blink for the front end, and then when we discovered that we couldn't, we had to, pivot. And then I sort of said, well, it would be simpler if we could get by using Blink as the server, because they have an open source server. And it seemed like the server architecture was not bad. So, and we were under some time constraints to get the product to market. So we decided to go with Blink as the server, and then basically they're claiming that it can scale in certain ways, and I'm hoping that it does. And we'll see, but I felt like whenever I added new functionality in a big chunk, I wanted to separate it out into a separate server so that I could scale that server with sort of a better approach than what I felt they were using. And so I didn't sort of pollute that code base. I've already forked their project. I don't want to modify it any more than I have to for things that they don't want to accept back into their repo. So if I build, for instance, we wanted to add, this was a requirement from the client very late in the game, adding subscriptions. And I'm saying, okay, well, we have to now accept payment in the client, which is not trivial. It's, we ended up going with ChargeBee, which I like a lot, but integrating that into Blink's server seemed like apples and oranges, so I built sort of a separate bridge server that could talk to both of them. That's an example.
All right, so we are going to be talking about static site generators now. Get into that. Okay, cool. So this second talk is going to be about exactly that, static site generators in the Jamstack. Some of you might be familiar with these. I'm sure everyone's heard of or worked with a static site generator in like some type of way, maybe. The Jamstack, maybe not so much, but we'll get into that. So this is the link for these slides. This is actually like a Dropbox paper document in slideshow mode. I didn't even know that was possible until today, but you could do it. Check that out. It's also, I put it on ithacawebpeople.com for today's event, so if you want to just go there, you can find the link there too, and that is where we will get Timothy's slides and information up on there as well. So like if you want to ever come back to this like thing, that's the way to do it. Okay, what are we talking about today? We're going to talk about what are static site generators, what is the Jamstack, and basically when is it appropriate to use these things or not. We're going to go through and talk about sort of the tools and the mindset. It's not going to be super code heavy or anything like that. Just going to be sort of talking about the like general like philosophies behind these things and like the sort of, you know, I don't know, movement or whatever you want to call it, the trend that's sort of going in that direction. So, about me. My name is John Robson. I'm the head of Funkhouse Ithaca. In this office, I run the tech for Funkhouse. We are a creative agency. We do branding and digital and websites for creative companies based in LA, tech office here. This is how you can contact me. You can just find me or email me or go on GitHub or Twitter or whatever. Cool. Yeah. So, oh yeah, right, Funkhouse. So that relates to basically why I'm talking about this, right? I have a few like disclaimers, I guess, that I'm going to go through here in a second. But one of them is that the whole like purpose of this talk is, or like this is very driven by like me sort of wanting to, like my use case for static site generators. That has a lot to do with the type of work we do. We do high-end like portfolio style websites. We build them on WordPress. Ben, you're it's like to the right or something, but also like if you click off of this thing, then my like clicker's not gonna work. Is there a problem or like? It's getting pretty loud. Oh, okay, got it. Okay, I'll talk quiet. No, but then these people won't be able to hear me. Forget the stream. Okay. I appreciate you though. Okay, cool. So we do these high-end portfolio style websites. We build on WordPress. And so, you know, we have like a certain set of requirements that I'll go through in a minute of like what actually like is the impetus for me like, wanting to like get into all of this. But this is the sort of work that I'm doing, and this is kind of like what triggers the whole like research into this this area. So, like I said, portfolio style websites, good use case for static site generators. My disclaimers that I mentioned a second ago are that only recently gotten into this. There's like static site generators are not like super new technology. Like a lot of Ruby people will be very familiar with like Jekyll probably, that's been around for a while. A lot of like, they've been a solution like a lot for like technical documentation for a while. They're like super good for that. I guess what I'm talking about is sort of a newer movement to use them for everything, some people would argue. And so that's like kind of the side of it that I'm on. So that's mostly, we're going to be biased in that direction. And I also am a Vue developer, so there's like a certain set of like tools that are like Vue-based that I prefer. If you're into React, it's going to be a lot of the same stuff because like there's like very good parallels, better tooling of course for React, like with everything. And so there's that, but won't be getting into like the more like, you know, legacy Jekylls and stuff like that. And, you know, there's like other ones in different languages. So let's go through what is a static site generator. Just going to give a simple definition, but this is an article from Netlify, and I'll talk about Netlify a little bit more, which you may or may not be familiar with, but they basically are a service that like optimizes in this type of thing, like static delivery, I guess. And tooling around that. And so they write about it a lot, so this is a good article to check out if you get the link to that, sort of state-of-the-art or the state of static site generators in 2017. But basically, static site generator is a tool basically that will turn you know, some data and some code into like static web files, right? So the language of the web is HTML, CSS, JavaScript. That's what we're talking about. That's what browsers read, and that's what they need to end up at the end of the day, getting delivered to them in order to like read a website. But obviously, we can't write directly in those languages a lot of the time because it's very cumbersome. It's things get repeated a lot, so we've invented like Sass and Less and like Babel to precompile all of our things, and like and then on the server side, like PHP to like actually glue the HTML strings together and like inject dynamic data in there and like query databases and do all this stuff. But at the end of the day, it just needs to be an HTML response. So a static site generator is something that takes a repository that represents like the sort of templating and like the frame for like how the site will come out, and a set of data, which could be anything, and we'll get into that in a minute, but like, you know, it could be markdown files, it could be hard-coded data in the repository, it could be databases or APIs or whatever, and it puts those things together and it creates the entire website as static HTML, CSS, and JavaScript. So that's my definition at least. And so, like I mentioned, like Jekyll, very, very popular, so any Ruby programmers might be familiar with that. This is a resource called Static Gen that I think is actually run by Netlify. They do like, since this is their thing, they have like a whole ecosystem of like static and like Jamstack style stuff, so there's going to be some of that. But this is basically a site dedicated to like keeping tabs on all of the generators that are out there that are options. This is a huge list. I have like a GIF later on of it scrolling through it. There's like, seems like many hundreds of them, but either way, there's lots of them. They're open source, closed source, like in different languages, like different licenses and whatever, and this helps you sort through them and then filter by like GitHub stars and all of that stuff. So it's a great resource to check out. Let's talk about the Jamstack. Jam stands for JavaScript APIs and Markdown. This definition here on jamstack.org is modern web development architecture based on client-side JavaScript APIs and pre-built markup. I would say that pre-built markup is like the sort of biggest part of like what a Jamstack like style thing is, but the idea is that the markup, the HTML that comes out is not getting rendered dynamically. It's not being rendered by a server. It has already been rendered and is just being served. And that's like sort of the whole idea. And then the other part are that like basically all of your like logic in your app or site or whatever should be handled client-side in JavaScript. So the like complicated or real-time or like whatever should be handled in the browser. The initial responses and stuff should be pre-rendered markup, and then all of your services, the thing that the JavaScript is working with is going to be basically reusable APIs. So that's what we're talking about. By the way, feel free to interrupt me at any point if you have questions or anything like that. I didn't, you know. Okay, cool. So this is a little bit further down on that website, just like basically showing these are some whatever. This is how it defines it. JavaScript APIs markup, but I think we just covered that, so I'm going to keep going. But before I get too far into that, I want to like sort of walk through my mentality on like my use case for doing that, because I think that's sort of some of the easiest way to understand like how at least I have found this to be incredibly valuable, and maybe some of you will find it in the same way. So, like I said, portfolio style websites, and obviously there's different, it depends on what you're doing. So you could be building web apps, you could be building stuff like this. This is a recent Funkhouse website for Imagine Entertainment. Basically like, it's a portfolio site. They have a bunch of work that they want to show. They've got a contact page, an about page, a front page. They want to do it in a cool way, but at the end of the day, we're talking about in terms of like pages, and, you know, there's a blog and stuff, but in terms of like pages and posts, you know, this website might get up to, you know, like 500 pages, 1,000 pages, like unique URLs or something, but that might be it, and it may not change very often, you know, like an ambitious client of ours might update their website 3 times a day, you know? And so based on that logic, you know, a lot of my thinking behind this is that like we're running WordPress to do this, and there's like a lot of great things about WordPress, but at the end of the day, it is a server that's like up all the time, that's sort of like doing database queries whenever it's requested, and you know, gluing strings of HTML together and everything else to actually like present this thing, when at the end of the day, if it's only 1,000 things, 1,000 pages or whatever, we could just like render that out all ahead of time. So yes. 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 Depending on your setup, by default, no. So there's no like default like thing in WordPress, or I think in most CMSs, that will just like cache, because that would be too aggressive. But most services, like when we do our hosting, we use a service called Flywheel, very similar to like WP Engine or any like dedicated like WordPress hosting. And what they'll do is they'll put like Varnish in front of it, or like Cloudflare or something, and at the end of the day, you're not necessarily with every request getting direct database queries and all of that stuff. But there are like, you know, we'll get into a case study a little bit closer to the end of the talk that's like, there's actually like a lot of, you would think that that would sort of end up being the same result as like sort of ending up with static files, but actually all the mechanisms that go into that, caching is not perfect, and you end up getting much better performance regardless of just serving it off CDN. But it's a great question. So the priorities for the type of work that we're doing in my use case is, we do high visual impact, and we need very consistent cross-browser experience. That has nothing to do with static site generators, but it is a priority. Performance is huge. Performance, it's got to be fast, it's got to load quick and look impressive and all of that stuff. Easy CMS, mostly at the end of the day, the content management system. That's why we use WordPress. But we need to be able to train a layperson to get in there and update any content across the whole website. And because of our high need for sort of interaction design and all of that stuff, modern tools like Vue and React are super valuable, and sort of hard to put them together with WordPress. So I'm going to talk about the existing solution that we have right now. This is what we do at Funkhouse. Everything that I'm talking about, static site generators and stuff, is sort of just very recent, experimental stuff. So we're not actually at least at Funkhouse, doing this in production. But our current existing solution is basically, and I could do a whole talk about this, I'm not going to go into this very much, but we built a little toolkit to put Vue on top of WordPress called VuePress. There's another more popular VuePress that came out afterwards, very confusing. But don't be confused by that. We're going to rename this one because theirs is way better than ours. Not better, it's different. It's just different. Ours is better. Okay, so so what does VuePress do? Basically, if you're familiar with WordPress, what happens is, I'm just going to give you the super high level because this talk is not about WordPress or anything like that. It's just happens to be this particular use case. What it does is WordPress is going to serve an HTML file that is essentially empty. So there's a blank div in the middle. It's got the head and the footer, which calls all the resources and everything you need. But there's a blank div in the middle, and there's a bundled JS file that is basically going to fully client-side render the app altogether. And this is a theme. That's all it is. VuePress is a theme. But it has a dependency for a plugin that basically turns the rest of WordPress into an API. So if you're looking at the about page of a website, if you request it in your browser, you get HTML that will render into the page. If you request it with a header requesting JSON, you will get just the JSON data that make up the about page. So that's going to be images and copy and everything like that. So by putting those two things together, you basically are able to, on first request, get the HTML you need and the bundle to render the app. Every subsequent request is a JSON-only API request to change pages and fill out the data. That's great. Love that. We use it for all kinds of stuff. What are the downsides of that? Oh, and then there's a whole thing that I don't need to get into there about SEO and how we sort of handle that by doing synchronous rendering. But either way, this whole thing works well, but there are some issues, right? Client-only rendering is always in some way a little bit worse than server rendering, right? Especially for this, you can make a really strong argument that I might get into later about apps, if the data is not public, think about Dropbox, Asana, something like that. If the data is not public, it's behind a wall, a login wall, then what does it matter because there's no SEO implications or whatever? You don't necessarily need server-side rendering if that's a full client app. That's totally fine. For these types of cases, we do want good SEO, and Google and basically every modern search engine can render JavaScript, and specifically can render JavaScript if it's synchronous, if there's no AJAX requests that need to pull in the data first. And so we did some research on that, and it's great. Our sites get indexed and everything, but there's, Open Graph, there's crawlers, there's screen readers, there's all kinds of other stuff to consider that if it comes off the server the way it's supposed to be, there's always going to be a slight advantage to doing it the way that the web is intended to work, right? So another downside, you end up sending a lot of unnecessary data on first and subsequent requests, right? Because the page load will come out with all kinds of data that it doesn't need, and so there's a bit of overhead there. And the big bottom line for me is what I already said here. That's just at the end of the day, there might be a website with only 100 pages or 10 pages or whatever. And at the end of the day, should we be doing database queries at the request of that? Template building, dealing with session variables, and doing all of that on the runtime at the time we requested it? Because in theory, that can all happen ahead of time. And so that's the whole motivation for this thing. So back to static site generators and all of that stuff, here's where my research brought me. My requirements for this type of stuff is that really I really want server templates, you know? I want it to come off the server like that. And since I'm using Vue for all of my templating, or if you're using React or whatever else, that means your server some server at some point has to run JavaScript. It's the only way. I want a Git-based deploy process to be like, you know, modern. That's just like super easy. You can branch things and deploy them and just have it sort of automated. That's great. And basically, like in an ideal world here, the final result is going to be like basically a pre-rendered app, right? Any request that I first make to the server gives me back fully server-rendered HTML the way that the browser would render it. From there, the client bootstraps and is now a long-running app, and so it has awareness of all the templating for the rest of the site, and as you move page to page, it should be able to just pull its data from wherever it needs straight from the browser and not really need that HTML again, unless you hit it direct another time. Is this making sense? Is everybody with me so far? Yeah, okay, cool. I feel like I'm going quick. Yes?
When you're talking about Git-based deploy process, is that for changes to the structure of the site or when the customer edits a page?
I don't care so much about doing a Git deploy process when like content is changed. I'm thinking more of like, you know, just like Heroku style, your code is in Git, and when you change it in Git, that is like the single source of truth, and it will like redeploy. And if there's database changes, we don't need to deal with that. If there's like other stuff like that, we don't necessarily need to deal with it. But specifically like having it all be like nice and automated like that. So yeah. Which is totally possible with WordPress, but it's not trivial. You know what I mean? It's not like there's tools that do it, but it's, you know, yeah, could be better. So yeah, let's keep going through this. So some popular tools. Here's what I was talking about here, scrolling down that page. Lots of static site generators out there. So like I said, not super new technology. A lot of them are developer-centric. So I already mentioned this, but basically, like, this was what I perceive as like sort of the earlier beginning. But I think that a lot of the motivation, yes?
I was just going to say one of the main maintainers for Jekyll used to work at Cornell, or used to be at Cornell, was at Cornell.
Oh, really? That's funny. Oh, a little bit of local history in here. That's what I'm talking about. Jekyll. No, so I mean, like a great use case and what I think has like powered a lot of the development of this whole thing in the early days is that like with GitHub Pages and stuff, it's so great like to have something where you can just have like a bunch of markdown files that render out to a website and build out your entire documentation. And that's not exactly what Jekyll does, but like, you know, there's things that do that and make it easy where you can kind of have like static things. You have a repo for like some project you're working on that's open source, and you, in that repo, can just make a little folder of like instructions for how to like build the site and then connect it to GitHub Pages or whatever else before GitHub Pages existed. And just have it like build your documentation website for you, and it's all like contained in one thing. So things on that initial list of static site generators, these are some of the popular ones that do specifically that. Specifically for technical documentation. I mean, Jekyll isn't, but it's very widely used for that. Jekyll, ViewPress, Gitbook. So, like I just said, great with GitHub Pages. That basically, actually don't use it that much, but basically will do some kind of like, deployment of just some files that you have in GitHub if they're static. Let's see here. Yeah, so then there's other ones. There's like, your static site generator or whatever you're using could be written in any language, right? There's Ruby options, JS, Python options, Go. For my use case, I want to focus on JS because, again, I need to render Vue templates or React templates or whatever you do. I want them to be isomorphic. I want the browser to be able to render them, and I want whatever is building them to also be able to render them, and that's important. So recently, there's a few more tools that are sort of closer to like the new, more forward-thinking movement. And so moving away from just documentation and thinking about like, what if we do like entire projects in this, right? And so Gatsby and Hugo are options of that. Gatsby is fully static site generator, React-based, super fast, JavaScript top to bottom. Hugo is Go-based. I think it's, I'm not going to actually say that because I'm not sure. But Hugo, Go-based, probably one of the, I mean, I think Hugo is maybe the most popular static site generator in general. It's been around for a while. Okay, so then there's a few other ones that are sort of attempting to even push it a little bit further. So I've got Next and the Vue knockoff Nuxt here that are both really great tools, but what they're trying to do is basically take server-side rendering and couple it with like static site generators, right? So they're trying to make one single framework where if you obey the framework and you work with it the way that you're supposed to, then a statically generated app should not be this different than a server-side rendered app. You could go, npm start or run dev or whatever, and you have a little server that will deliver markup, like rendered markup with every request, or you could do run generate, and it will just go through every single page and render them into static HTML files. That's what these two are trying to do. They're doing it well. And then Gatsby is a super interesting one. It doesn't do the server-side rendering dynamic side of that. It only does the generated side of that, but it is trying to basically decouple. It's trying to make it so your source can be anything. Gatsby is React-based, like I said, very fast, and it has its whole like system is by having like plugins that are like adapters. So you can like wrap Gatsby around WordPress. You can wrap Gatsby around just Markdown files. You can wrap Gatsby around like a generic API or something, and it will pull all of its data from that, read the pages that it needs to actually get, the content, the images, whatever, compile, pull all that out, render it through templates, and just build it into like files that can just be put on a CDN. So those are trying to make it so that you can basically build anything using this like mentality of like, you don't need a server just like doing work and serving things. You literally put them, you can have you just have static files and you can put it on anything. And I don't know if maybe this is, we all know this, but the benefit of having just like pure small static HTML, CSS, and JavaScript files is massive because you don't need to distribute servers. You just put them on a CDN network globally. They serve incredibly quickly. I think that you could put them on Cloudflare. You could put them on Netlify or whatever. They can be distributed. They're very cheap to like, we'll get into this later, but they're, you could have different branches that just generate different versions of the site, and it's incredibly cheap to serve like an infinite number of copies of your site if you want to or whatever. And also like, I think that I read somewhere, somebody fact check me on this if this is not true, but Cloudflare, if you just have if your entire site is just like a few static files on Cloudflare, then you can essentially, I think that Cloudflare can withstand fairly easily the like largest recorded DDoS attack that's ever happened because it's built specifically to be a global CDN to serve these things super quickly. That's what it does, right? It's supposed to be the wall in front of your website, but you can also just make it the website, right? There we go. So they're trying to make it so that you can build any app like using this system, right? But any app, how does that actually work, right? Because obviously static files are great, but what they don't do is anything. They're just data, right? Like they're just like sitting there as data. So like we need to do all these things. What if we need e-commerce and like authentication and all these things? Like how do we deal with that? So there's a whole bunch of mindset and like tooling that sort of goes along with this. How does Jamstack deal with this? Well, the most simple version of Jamstack is probably something we're all familiar with, which is just like separated client and API, right? So you have like you have one app that runs and it has no data in it, and then you have a separate server running just like an API, and it is pulling all of the data dynamically and like doing, like actually using that to render the pages, right? So that is something that's been a popular like, what do you call that? Like a popular setup for a while, but that sort of counts because if your client was like static, then that's kind of like Jamstack thinking, right? But there's been even more of a push to go like more serverless, right? Microservice architecture. So there's things like you need authentication. Maybe you don't have to build it. Maybe you just have one little server that just handles your authentication, or maybe you don't even do that. Maybe you offload it onto Auth0 because that's what they're trying to do, like zero no, just authentication once. Authentication as a service, right? You pay a little bit of money and your authentication is handled. You don't have to roll it all yourself. That's Auth0. What about Firebase? Has an entire ecosystem for dealing with these kinds of things. If anybody's worked with that, they do databases, storage, analytics, all as like separate little microservices that you can kind of interface with. You can interface with them on the server or the client, but for our purposes, we care more about doing that on the client side with JavaScript. And then what about, you also have just general purpose computing. We've got AWS Lambda, which I'm sure some of you have experience with, or just Google Cloud Functions, where you can just do some amount of generic work in Python or JavaScript and just have like one little endpoint that does that. And so maybe you have some work that's done and your browser can just interface directly with that, and that will get the job done for you, right? And there's even e-commerce. That's one that seems like it would be really hard to actually solve this problem on, but Snipcart is a good example of a service that is trying to be fully supportive of this style of thinking, sort of like a toolkit that you can just interface with through the browser and have like a full e-commerce experience. Like we're talking about here, if these things are static, how do they actually stay up to date, right? Because if they're rendered, they can't be rendered all the time. How do we do that? I guess sort of two options here, but they're not different. Data that's updated frequently is just handled by the browser, right? Like we said, your work is doing that. You got something that's real time. You have something that's updating every 100 milliseconds or something. That obviously your static files are not dealing with that. Your browser is powerful enough to do it, so find a way to do that, right? Data that changes less frequently can be sort of snapshotted, right? And that's kind of in my scenario where I have maybe a client is going to log into the back end and they're going to change pages a couple times a day. That's very infrequent. And builds are cheap. So you can, if it's 3 times a day, you could do that, right? If it's even more than that, you can have someone change some data. That can trigger a build process. That will rebuild all the data, and within a minute or something, you basically have the site up again. It's also important to note that I guess this isn't true for all scenarios, but if your app is pulling from the live service, the architecture that I sort of described before is that you only get the HTML on the first request, and that's going to be the built hard-coded HTML. Subsequent requests are going to be pulling straight from the APIs. So any data you get through your services in the browser will always be up to date. It's just the data that's actually baked into the static files is going to be slightly out of date. So in things like e-commerce, that's actually, you would think that might be dangerous because someone might see the wrong price of something or something like that. But at the end of the day, really, you can have it so that anytime someone changes the price of a product or whatever, the thing rebuilds. Someone can add it to their cart. There might be a minute of margin of error there, but by the time the person actually is interacting with it, adding it to their cart and whatever, the data is actually pulling from live servers and the data is up to date. So that's how that works. When should you use this, right? Because I've been sort of pseudo making the argument here that you can do anything with this, but obviously that it doesn't. You shouldn't for everything, right? And so I think that one good question to start with is do you have a reasonable amount of unique pages, right? So again, this is Bunkhouse client site, Pretty Bird. They do director representation and they show off their work basically, right? And they actually have a pretty big site and they might have 2,000 pages or something in there. That is a reasonable amount. What does an unreasonable amount of unique pages look like? Asana has these hashes in their URL for every single task for every single user that's in there, and it all gets pulled dynamically. You obviously are not going to generate pages for every single combination of URL that you could have here because it would be ridiculous. So if you're building something that's kind of this more walled off app, you don't want to do that. And like I mentioned earlier, you can make a strong case that it doesn't even matter if you're doing this, right? Because it's client side, right? In the case of Asana, you don't actually need the server-side rendering because the client can handle all of this stuff. But Asana actually, I believe, is server-side rendered. Dropbox is server-side rendered. So you may want to make that decision anyway, even if it's not public-facing. Many people would argue that client app is appropriate here, but if you really need to do server-side rendering, then there are these options where the tooling can be the tooling can be the same, right? Like I said, next, next, and next. I'm going to get into these a little bit more because specifically I landed on ending up with next in my use case, and I think that they're super interesting. So I sort of already went through this, so I'm just going to go through it quick. The philosophy here is that you put the structure, they're using Vue and React to actually like render these things as like the templating engine, but if you put the structure around it and use it in the way that it wants to, then it's fully unified and it will do like the server-side rendering or generation at the same time. So when you have this set up, what's going on here? npm run dev will make a little hot reloading server-side rendered server with great debugging. npm run build will just compile everything into like a production app that when run will run the same thing as dev but the production version of it. npm start is going to give you it's going to actually like run that production version, and then npm run generate would give you basically export the app is a good way to look at it, right? It starts the production version and then it maps through every single possible URL on the site and finds out what the response from the server would be and then saves it as like static HTML files, CSS, JavaScript, everything else. That gives you a little dist folder, and that can just be dropped right onto a CDN. So again, next and next, these are the things that are trying to do that, unify it all, Vue and React respectively. Cool. Gatsby. I also basically covered this, so I don't think we need to go into it, but different philosophy. They don't do the server-side rendering. Similar concept, but they're just doing the static generation. Here's their way of saying what they do. You have different data sources. You could have CMSs like Contentful, Drupal, WordPress, whatever. You might have just static markdown files. You might have data coming from APIs. You might just have YAML files. You might just have like CSV spreadsheets somewhere, right? It unifies the whole thing into like a build process that then makes a common interface powered by GraphQL. And then the front end is able to sort of, interface with that, but it has all the data at this point. It's gone through the build process. It has the data. That's the idea behind Gatsby. If you like GraphQL and you like React, it's a good option for this type of thing. And then you just serve it with anything you want. S3, Netlify, GitHub pages, whatever. Yes?
So I don't do a lot of WordPress, but does WordPress have a simple solution for being able to provide all its data via the API? Because my experience with WordPress, it was all like the PHP templates.
Yeah. So there's a relatively new, but it's in the last few years, they've developed a full like JSON API basically where you can do, I think basically anything that you can do in all of the back end of WordPress, you can do through this JSON API. It's got authentication and you can do all kinds of different things. So you can read it. So basically any like WordPress website that you go to now that's like up to date, you can hit /wp-json/v2 or whatever, and it will just return JSON of like, you can search users and pages and like posts and all that stuff.
Is that a service only for administrative view of the data? Or
No, it's, by default, it's actually the things that are readable by default in WordPress are readable. So any site that has that and hasn't changed that configuration, you can get a feed of all the pages, all the posts, all the users,
that's how this would hook into GraphQL. There would be some sort of fetcher.
Exactly. Yep, there's a wrapper that Gatsby maintains that they have built that wraps around the WordPress WP JSON API so that they can crawl through the whole thing, generate all the pages you need, and then make it accessible through their like common GraphQL interface. Presumably, I don't know anything about Drupal, but presumably they do the same thing for Drupal and like all these other things, right? So, yeah. Like I said, data source can be anything. We already went through that. And then, everything gets bundled into a static app. So let's talk about data for a little bit. Like I said, high priority CMS in our case because we need non-technical people to go in here. Also, different projects have different needs. Is WordPress the best solution for every project? Definitely not. So having something that's sort of CMS agnostic is like a great thing. And so Gatsby is a great option for that because, again, it wraps around it, but I don't love React, so that's a personal choice. If you like React, do Gatsby. It's a great thing. And, of course, like I said, if it's JavaScript-based like Gatsby are, it's great. You can build an adapter that will just like be isomorphic and pull your data, whether it's building or whether it's running on the client. So that's super helpful, too. this answers your question, Greg, right? This is the JSON API. I forgot I put the slide in here, but this is like the documentation for it. So WordPress is being more like forward with that. Because there are lots of reasons you might use WordPress as a CMS, but maybe you don't need the front-end templating because you don't like PHP because there's things wrong with it. This is an aside, but like if you're interested in this, if you work with WordPress and you're interested in this whole idea, they also have developed this open source piece of software called Calypso that basically is fully React powered. It powers WordPress.com, which is like the separate like sort of blogging like social platform engine that they have. But it's essentially a piece of software that allows you to connect to one or many WordPress installs through the JSON API and control all of them, and it has everything rendered in React, and it's sort of like a wrapper thing that controls all of that. So on their WordPress.com product, that's how they control separate instances of WordPress, is using this thing. It's all open source. You can dig through the code, and it's super interesting. Yeah, so those are like existing websites, and I'm sure, or existing CMSs, WordPress, Drupal, that kind of stuff, moving in that direction. But also, there are now a lot of headless CMS options, which you may have come across, and Contentful is, I think, by far like the market winner in this area so far. Contentful is it's basically like a hub for like all of your content, right? But essentially, they have ways that you can interface with it as a CMS. They have like a whole back end, and then also it's very easy, lots of SDKs for like developers to interface with it too. But the whole idea of a headless CMS is basically if WordPress didn't have templating options, right? It's like all it is the API. It's just a back end that provides an API. You can make pages and posts and users and whatever, and then it just exposes an API to work with those and does not care about serving HTML. It doesn't care about like anything that goes along with like normal website stuff. Another one that I really like is Prismic. It's like Contentful Lite because Contentful is very complicated and can get expensive. And that way Prismic is very simple and easy to use. So the benefit of these, just like headless CMSs in general, of course, are like you can, friendly CMS, anybody can log into, they're modern. These are like both software as services, so they're constantly being updated, maintained by a team. Allows for user-friendly updating. And then, of course, anything that ingests an API can use that content. So in our case, that's the static site generator or Next, or whatever you're using. But basically, anything that can read data out of its API can actually use that thing. Contentful and Prismic, both great examples. There's also a lot of open source options. This is, again, one of those Netlify sites, or Netlify-powered sites, that keeps tabs on all headless CMSs. There's a bunch of these, too. But there's a lot of open source ones if you want to run your own server, not have it be like a closed source type of thing. This one right here, that's like the top one there, is like a JavaScript open source CMS that I've never worked with before. It's called Strappy, but it seems really interesting, and I don't know. I've like played around with it a little bit, but that seems like a interesting, like gained a lot of momentum contender recently, so it's worth a mention there. Like I said, in my use case, what did I land on that like solves this sort of like portfolio site problem for me? I think that Nuxt and Prismic is a super interesting option for this. So this is Nuxt. This is the, that's Vue.js apps that are server-side rendered or generated or whatever you want to do. Like I said, either one, they can both be run. So if you you can run it, you could just run it on Heroku, like npm start, and it'll just deploy your Nuxt app, or with exactly the same code and almost no changes, it can just do generate, which can be built by anything, Netlify, GitHub pages, or like a Lambda server that deploys it to Cloudflare, like whatever you want to do. It has code splitting by default through Webpack, which is really cool because as you go page to page, you only get the actual code that you need. Has intuitive isomorphic data handling. So that's what this looks like. Even if you are not familiar with Vue at all, it's probably easy enough to see what's going on here. This is like the core. I've just, snapshotted this from like a sort of larger component here, but this is like the main thing that sort of makes the magic happen that like Nuxt enables here, which is just one function that's asynchronous where you tell it how to get the data. And so this is like the Prismic Prismic SDK here in JavaScript. We like just wait for that to bootstrap. We pull some results querying for one page that has the ID front page, and then we set it into our store, and that's like a Redux store if you're familiar with Redux, I guess, React. That makes it accessible to the rest of the app. The important part of this is that this will run in any of three contexts to make this work, right? This fetch function, if you're doing generate to generate your entire app, will run, for every page to get the data for each page, and it's being run by a node server that's doing the actual building. If you are running it as like a live node app that's like serving responses, then it's running on that server, also in a node context, and actually like server rendering on the fly. Or once your app has actually like bootstrapped, it's running in the context of your browser, and this is actually like AJAX calls rather than like server-side calls. So it sort of works in both contexts, and it's good for that. So what else does Nuxt have? It's got good transition APIs, which I think is cool, moving from page to page. Got really great tooling for handling page. One of the problems you encounter with this is like, how do you deal with like open graph meta tags and like other meta information that you put into like the head of your page? Because everything is dynamic and the data comes from God knows where. So like, how do you do all that? So it's got great tooling for like dealing with that. It's good. What do I like about Prismic? Prismic is super interesting, simple, not expensive. Powerful. All data in Prismic is immutable, which is pretty interesting. So it's a CMS, but like you model out your data, you make pages, posts, like users or whatever like your actual data looks like. Could be anything. And then you make versions of that data. You tell it how each thing is going to look. So I'm saying I'm making pages, and a page is defined by a title and some body copy and image, right? That's how you model it out. Then you make a page, and it's immutable. So every time you change that page, you're making a new version of it. And because of that, each version of it that you have gets a unique REST URL where it will never change. And the interesting part of that is that, number one, you could cache it forever because the URL changes. The data doesn't change, right? So that's kind of interesting. It also makes it really easy for versioning, previewing things, A/B testing things, because it's got all of this like complex versioning systems built right in. Not going to get into any of that, but it is a cool thing. And another benefit is that at the end of the day, all this immutable data just ends up as like JSON files that are going to be accessed through an API. And so they actually just throw those up onto a CDN, right? They're never going to change. They could just put them on a CDN forever. So each version of a piece of content gets its own URL. It also does things built in like full text search, flexible content tagging, that kind of stuff. So it's powerful, and it's also very fast, which is good. So what does my deployment process look like in this scenario? Sort of drew out this thing, right? So we've got a client, a human, going into the Prismic backend and changing content. We also have me, Mr. Developer, going in and changing code in GitHub. Both of these things require like updates, but like we said, build processes are cheap. So any changes go into here, and then they all go into Netlify, and Netlify is the service making all of this possible. So it does build and deploy, basically. It's watching for these things to happen, and when they do, it boots up a little node server, it pulls all the code in from my Git repo, it runs the build command, which crawls through the Prismic API, builds out all the pages, and then deploys them to a CDN that is, super fast. That's it. As changes are pushed to the master branch, they just automatically get put to Netlify. As Prismic changes content, same thing. Like I mentioned before, another big benefit of that is that, it does this build process through the Git repo in a particular version and then deploys to the CDN, but I can also just branch it really easily. All the data is going to be still in Prismic, so if I'm working on a new feature and a client needs to see it quickly, I could just make a branch, build the thing, make a new deploy, or make a pull request in GitHub, and Netlify will automatically spin up a different staging site with a different URL that is pulling the same data but running my new feature on the app in that version. So that works. Netlify, again, I've talked about it a bunch so far, but it's just their whole thing is that they're trying to make this style of development extremely possible. So their main core functionality is that deployment, sit on a CDN. It's totally free because like that is not, they make their money off of like the things around that, and CDNs are so cheap to serve files. So you can do this whole build deploy process, just hook it up to a Git repo. It'll run it to a website. You can put a live URL on it, and you can deploy it with HTTPS fully and have it there forever for free, just by default. So you only start paying for things when you go getting into this other stuff, which is like what we talked about before. You start needing work with these other things. You start needing some generic work. You're going to need some functions. So they've got a little abstraction for like Lambda functions. You need authentication. They've got this identity. They've got these forms. You don't need to use any of these things. You could use any of those other things I talked about before, Firebase or just straight Lambda or whatever, but they're trying to make it easier on you. And then, like I said, this is how it ends up looking. So like these changes over here are like raw changes. So if I push to master branch, it would just deploy automatically. Also, if content changes come in, there would be a different version of this that's like content change, that triggered a build. And so these, you could just watch these live and they go in as they happen, they'll build. And then also over here, any pull requests end up going over here and like automatically getting deployed as like a separate URL. So what's cool about this, like I said, the A/B testing thing. Also no local environment because you don't need to deal with any of that, the server or anything, right? Prismic is like a service. So basically any of you could go in, if I built a site this way, anyone could just go into the repo, just go pull down the repo and go npm install and run dev, and you'll have exactly the same version of the website that's like deployed, and you can start making changes to the code base. Super light. What was that? Oh, actually, I don't know what their like expiring process is here. That's a really good question. I'm not sure. Presumably, they take them down at some. I mean, I'm sure you could just go in and like delete them off of here, and the URLs are like have like the Git hash in them, so they're like 1 million characters long. But presumably, they must like expire these and like delete them at some point. But yeah, good point. They just hang there, right, forever. So yeah. Cool, so the end result is basically, I guess, what I was looking for in the beginning, right? CDN hosted versions of the site, all the static files, every page of the site is a rendered file. All pages represented as individual HTML files with pre-built markup. The first request, we're just hitting a CDN, we get that to the browser, it can read it instantly, and then it starts booting up the JavaScript and doing everything else. From there, it's a long-running app, so it starts any of its like live data things or like any important things that need to happen there. And then every consecutive request after that is like asynchronous, pulls straight from Prismic for the data. Since Prismic is also built on static files, both the build and the data are served from CDN networks. The content is served from a CDN, the site is served, the files are served from a CDN. That makes it super, super fast. Building sites this way, easily the fastest websites I've ever built. Not even close to like super optimized WordPress. App bundles are split into small chunks, loaded by Webpack as needed. So like if you have some crazy stuff going on your About page that doesn't happen anywhere else, you will not actually load the JavaScript for that page until you navigate to it, which is handy. Last thing here, the last thing is a really interesting case study of a company going through this process. And the company is Smashing Magazine, which if you're not familiar, they do like, they write about like tech and design, development heavy like articles a lot of the time. And they did this in a partnership with Netlify, which is interesting because both Smashing Magazine, what they do is write about stuff like this, and Netlify writes about it a lot too. So it's very good visibility into like how this whole thing happened. But, oh no, what happened? My clicker broke. Yep. Actually, no, okay, all right. You know what? Here we go. I'm gonna just take this keyboard, just run it from here. Here we go. Okay, we're almost done. We're like so close to the end. Okay, so, oh my God, what? Is my computer just crashing or something? No, okay, all right, so this is what Smashing Magazine looks like. I promise this is going to be quick. Online publication writes about design and dev. One of the most heavily optimized WordPress installs. Obviously, they've got thousands of articles and millions of hits all the time, and like they need to actually do it. So a lot of contributors. They had to split it through a bunch of different code bases. Lots of basically every WordPress optimization plugin that you can imagine was like tried on these things to actually do all of this like caching and all of that stuff. And their code base was split up in a million different places because they had e-commerce and all these different things. So they wanted to unify it. One of the Smashing Magazine does articles that are written by other people, like a lot of publications do. So one of the founders of Netlify ended up writing an article for Smashing Magazine about static sites and used their site as an example to do a little analysis and came up with, well, now it's working again. Okay, and came up with the claim that Smashing Magazine, the whole site could be sped up 6 times page speed increase if they just moved the whole thing to static site files. So Smashing Magazine was interested in that, and they started a big, long process in 2017, I think, to rebuild the whole thing on Hugo. It was on WordPress before. Now it's on Hugo, Go-based static site generator. They gave it a shot. They rebuilt it with Hugo. In the end, they got a 10 times performance increase. And everything unified into one code base. And there's a whole, I would encourage you to like read more about it if you're interested in this at all, because there's a lot of stuff that they did. Netlify did a lot of like open source work in tooling to handle these other things because Smashing needed advanced search, they needed e-commerce, they're selling things, they needed user accounts and authentication, and they needed comments, and many other things like that. And so they had to sort of go through these things because of the challenges of actually getting it onto a static code base. But the payoff, obviously, is that now the whole thing is incredibly fast, and it's not a giant monolithic WordPress install, and instead it's all just powered by the repo, and it's all in one place. Great. Okay. Resources. Again, you can find this whole talk on ithacawebpeople.com, and so like if you're interested in any of this, go through some of these links. This down here is a really good one, YouTube channel that's actually done by Netlify. They do tons of like thought leadership and just talks about like Jamstack style development and site generators and all of that stuff. That's all that I've got. Does anybody have any questions? Yes. Thank you.
So, question about cost. So you're using what's it called?
Prismic? Yeah.
Prismic and Netlify. Do you find that the cost of those 2 services is analogous to like a WordPress hosting, like through the engine? Is it less or is it more? Like, what are the scaling factors?
Yeah, it's a good question. It is. Well, so you kind of have to break it up because like Netlify by itself is like crazy. The actual like server thing, the hosting thing is actually like crazy cheap. So that's like almost, and even if you just put it on Cloudflare and had like massive traffic, you'd be paying like cents to serve it. You know what I mean? So like that is always going to be cheap no matter what. So the actual cost is really just in like Prismic, the content side, and that particular part can come from anywhere. Like so, like those some of the static site generators will work in like will just work off of like Markdown files and stuff. Obviously, clients can't go into GitHub and change Markdown files, but the point is that the data can come from anywhere, so that's where the cost comes from. Prismic itself is based on like you pay for how many like users you have registered in the back end, not by like performance or how many requests you have or anything like that. So for like 3 users, it's like $7 a month or something, right? I think WP Engine is like $40 a month for like 1 WordPress install for the lightest package or whatever. So yeah, if you are not adding 1,000 users, then yes. But you could also use any other CMS. If you find Contentful to be cheaper, it's not. But if you find anything else to be cheaper, you could do that. If you want to use, what's that other one called? Like the JavaScript like CMS that's headless that I pointed out, you could host that on Heroku for $7 a month. You know what I mean? A lot of options. So as long as it gives you a back end and serves your data in some way, you can use it. So yeah. Yes?
So what are you using for the client experience for editing data? Is that through Prism?
Yes. Yeah, so Prismic is like a WordPress competitor type thing where all it is the dashboard. It's just a dashboard that turns it into an API. So like you can register users in there, people can just log in and they have like different roles or whatever of like authors and stuff, and people can go in and change the content. You define how the content looks when you like set up the instance, where like how many images are on the about page, how many like paragraphs of copy are going to be on the front page or whatever, and then they can log in and just edit any of that stuff easily. When they do that in Prismic, Prismic has a webhook API, so when any content changes on the whole thing, it fires off a URL into Netlify, which then triggers a rebuild. And again, that takes about a minute, so the data's a little bit behind, but only on the first load. When you load consecutive pages after that, it's up to date because it's pulling off of the straight API, if that makes sense.
Do they have WYSIWYG preview, or do they have to wait the minute to kind of like, they write a new article,
Yeah.
and they see it as it is on the final site?
That's a really good question. There's not a way that you don't have that kind of control in Prismic because it's like a service, so you can't, like in WordPress, you can kind of like style the backend if you want to, and some people choose to do that. The way that they deal with that is they have like a previews API that I haven't like used, where basically since all of their versioning happens, if you build it into your app, I'm not going to be able to do a great job of describing this, but if you build it into your app, this like preview capability, then it can have a button in the back end that will basically send the user to like a specific preview URL where it will pull in that data but render it in the template that it's supposed to be in, and they can like see it ahead of time before publishing it. I haven't actually done that yet, so like I don't know how crazy that is, but that's their solution for that, which I think makes sense. You can also have like, you can add like little admin buttons onto the site to connect into the backend pages. So like if you're in the About page, you can have a way of adding a little button. Only if the user is logged into Prismic, they'll see the button that says like edit this in Prismic. They click it and they go straight to like that paragraph like in the backend of Prismic, if that makes sense. Which WordPress does like a similar thing with their like edit buttons as well. Yeah, anyone else? Rad, cool. All right. I think we have plenty of beer left. There's a